Untrusted data is a very important concept in security, and it's something we touch on when looking at the number of defined risks, which depends on information provided extremely to the system and frequently from the user. And when we talk about the untrusted data, we are talking about the few different key attributes. So first one is the integrity is not verifiable. It has been sourced from outside the system, so we don't necessarily have confidence that it hasn't been manipulated in some other way outside. What the system would normally expect that may have been happened is the user browser, so it may have happened by a man in the middle. So there are various ways with the integrity may have been modified. So the other thing we have got to expect that the intent may be malicious. So we need to expect that every single piece of data command and the data system could have been an evil intention. Now of course, once a piece of data contains a malicious payload, it may have a objective such as executing a SQL injection or attack, which we will look a little bit later on a cross-site scripting. So which looking at now, it may even be like there is some binary containing and some malware, and everything we see there is untrusted data. So we as a developer need to expect that it may be provided to the system in order to do evil, and we need to protect against this potential risk. Let's have a look at some of these places that untrusted data can come from, and the obvious one is from the user. So how does a user provide untrusted data to a system? Where the first thing is there is this query string or any other attributes of the URL. It's easy to user to change the URL to manipulate parameters in a URL, and that's something we'll be looking at more in the details later on, and we'll talk about it with the parametric tampering lecture. So of course, the other channel where the untrusted data frequently comes from the user is by a form of data in a post request. So they fill out fields on a web page, they click submit, and we cannot trust that data. We must expect that that could be malicious because ultimately it is untrusted. Another source of untrusted data is from the browser. So even the most legitimate of request from the user still causes the browser to send particular piece of data along with the request. So for example, in the cookies, we must expect that the cookies could be manipulated. So it's a very easy to simply reconstruct a request and manipulate the cookies, and particularly later on as well, we start looking at how we can use the composer feature of Fiddler. So and we will see how easy that is to use the Fiddler application. So there are some attributes of the request header. So for example, the user agent, every time the browser hits a web page, it sends the identity of the browser and the version of the operating system and other related information in the request header that can be manipulated by the attacker. So if for an example, the application has a SQL injection risk, so when it looks at the language used in the browser, which is a part of the request header, and that could exploit that by manipulating the value of a language header in order to leaving room malicious payload, and they might do is to there is a tool such as called Fiddler, and finally there are a bunch of other location of untrusted data that came from. So for example, if you consume an external web service, that is a source of untrusted data. And if you need to make an assumption that there could be malicious payload in the data, not necessarily, because the system you are consuming and that you are consuming it is from is what is doing is trying to do the evil, and but what happens is if it gets the compromise that affect your own database, and that could have a untrusted data. So if you accept untrusted data from a user via the reform input and then store it in your system now has a untrusted data in it. And this is the one of the things we look at when we look at the persistent access risk in this upcoming lecture. So in the last thing we will look at before moving to the another application itself is the concept of input sanitization. And what we are talking about here is the system saying, hey, I am receiving a untrusted data from the user and I am going to apply some filter criteria to what I think is acceptable and what is not acceptable. So if I get something which is not acceptable, then I am going to throw up a exception or reject the request to take some other sort of defensive actions, and in order to try and protect myself from a potential malicious attack. So as for example, you will often find system rejecting characters such as hyphen, brackets, single quotes, slashes, double quotes, backslashes, semicolons. You have probably seen it before you, where you go and either one of these characters into a field and have it rejected. That is the input sanitization, and there are a couple of different approaches a developer can take to the implement sanitization, and the first approach is to which is very specific about what you want to reject. So this is what we call lackluster approach, where the system is saying, hey, there are some characters I do not trust, or conversely anything that is not this character must be. So okay, now that's a very simple approach, but it's also very rudimentary and it also has some holes in it. It's very easy for that approach to be incomplete, and we're going to see an example of it. So on the problem, you may know or you may think that what a bad character is today, but if the new attack factory is discovered tomorrow, your system may still be at the risk. As a far from explicit way of implementing sanitization is to use what I would refer to as a whitelist. As previously we talked about the blacklist, so it is a whitelist approach, and a whitelist is effectively the inverse of a blacklist, where we say there are the characters that we are no good, so this is what we trust, and anything else we are going to reject all of that. Now this is a much more comprehensive, because if there are things that are potentially bad that we don't know yet how bad it is or how long they are the part of it, so whitelist that we are going to be pretty safe. So there are various different ways with implementing whitelist depending on the types of the data. So an email address, for example, is very easy to implement. What this case is there is a spec of email and there is a regular extension that can be written to validate an email, and that's a easy one. So we don't have to explicitly say an email address can never contain, say, a single quote. Instead, the whitelist will talk about the things like allowable characters and the inclusion of an @ symbol, that other attributes that make up a well-formed email address. It is a little harder with the things like names, but there is still regular expression that allow common language characters, and of course there is always a edge cases, and it does get a lot more difficult when you start talking about multiple characters, languages and some punctuations, but you can usually get a white list which is pretty comprehensive and keeps out of the typical characters that he used in a text such as cross-site scripting and SQL injection. So that's all for the untrusted data.